No, Brian won't be here today, Mike, so it's just going to be me and you. And we are live. Summit Racing fans, welcome to our normally on a Friday, but today we're mixing it up a little bit on a Thursday Facebook Live. Thank you for joining us today. Today I am joined once again as a follow-up to our pre-SEMA conversation with Mike Copeland. Mike is the CEO of Arrington Performance. They do all kinds of awesome late model Hemi products. If you did not join us last time, I'll give you a little bit of a quick background on Mike. Mike is a gentleman who has worked in a variety of capacities in the automotive aftermarket for many, many years. He worked at GM doing a lot of product development and project development. He's built cars for the likes of Jay Leno, Reggie Jackson, as well as many, many other incredible vehicles that were used for testing, research and development, and evaluation at GM. And Mike joined us last time with some very interesting news. Behind him is a Chevy truck that Mike and his team put together that is absolutely amazing. And now we can talk freely about this, Mike. So I'm really excited that you're joining us today because we're going to talk about a hydrogen-powered LS-based truck that makes really good power. It is the first of its kind, and it is absolutely awesome. So Mike Copeland, Mike, thanks. Great seeing you. Hope you're doing well. You've had a whirlwind of shows between SEMA and PRI and taking the truck around and showing people the zero emissions option of hydrogen. So Mike, thanks for joining us again. It's great to see you.
Well, thanks, Al. It's great to see you too. So happy to be back. Sorry I couldn't share with you more before, but we can certainly open up and share a whole bunch with you right now. So
awesome. That'll be fantastic. So my partner in crime, Brian Nutter, is unfortunately not with us today. He's a little bit under the weather. So Brian, we're thinking of you. Hope you feel better soon. And I'm sure you'll be back with us once again. So I've got a list of questions, Mike. So lots to talk about today. A lot of cool technology in that. Let's just quickly do, though, a recap of the SEMA show. So what was the genesis behind the project? Did you just wake up one day and say, you know, I'm going to build something hydrogen powered that doesn't make any emissions, and I'm going to take it to SEMA, and it's going to be one of the craziest things the world's ever seen? How'd this start? How'd you get into it?
Well, so the hydrogen truck is just the next step in a 25 plus year relationship I have with people at Bosch. So way back when, I worked with Bosch since the 90s, worked with them all the way through, they support a lot of GM programs. If you don't know, a lot of the cars run their computer systems in them and a lot of their parts. And so I've known, a number of people there for a long time. And I used to run the build center up in Flint, the electrical side of that. So I knew, I worked with them continually, right? So built some friendships. They have some real gearheads inside there. Well, I mean, like in 2011, we did together the Jay Leno Camaro, which was the first ever twin turbocharged direct injected engine that was ever built. So they supported me from an ECM calibration and a component standpoint. And I built the car and did all those things. As part of our agreement, I supplied them a complete set of parts so that they could build their own car the same way that we built Jay's car. Well, flash forward another whole bunch of years, 10 years or so, and they were the guy that I met way back in the mid 90s and is a personal friend, had climbed way up the ladder in Bosch. He was getting ready to retire. So they wanted to a lot of the engineers we had worked together with through the years and all that stuff, we were going to have a little reunion because he's retiring and moving out of state. So they wanted to come to my shops and gave him a tour and then just a big old BS session. And that led to a conversation about hydrogen, that they had some experimental parts. They had a little tiny engine running on it over in Europe, and a bunch of conversation. And we came to an agreement that I would build a truck and I would set it all up to run on hydrogen. I would, handle all the fueling system and all those things. And they would help me with the parts that they made, experimental parts, and we would go for it.
That is awesome. Hey, Mike, before we continue, Derek, could you click on the comments section for our Facebook Live? And I just want to mention to our audience, if you have an opportunity, throw a question out for Mike. We are going to cover a lot of material today. We're going to talk geek, as I like to say. So we're really going to get into all the intricacies and a lot of things I personally, and I know our customers are going to be really curious about, with how in the world do you get an LS-based engine to run on hydrogen? And Mike, before today, you and I have talked a bit about this, and you know I'm a gearhead. I'm always fascinated by technology and what's new. And some of the things I want to ask you. So now the truck at SEMA, I know you were trying to get the hydrogen tank through customs, and you were having all kinds of headaches doing that. And I know now you do have it. So does the truck run and drive right now? And is it, have you put any miles on it?
Just a very minimal amount. So so we have the tank's installed. We're still struggling to fill the tank. There are no hydrogen filling stations in Michigan. And there are a few, but they're privately owned. Toyota has one, GM has one, but surprisingly, they haven't offered to let me use theirs yet. But anyway,
hey GM, are you listening? Give Mike some help, would you? Come on, let the guy fill the hydrogen up.
There's a few universities that are using some hydrogen and things. So we're making progress in that arena. To this point, we're still running it on portable welding tanks, but we have laid one down in the bed of it and driven it a little bit. We've been working through idle sequences and all those things, and we've made great progress there. Been working on cold start, been working on transitions, throttle transitions, and as you can imagine, all of that's different between hydrogen and gasoline. It's all programmable. We've had to open some parameters up in software because we operate in ranges that traditional ECMs don't. So we've done those things, but we're making great progress, and I'm very optimistic about where we're going. And I'll tell you this is a little bit tentative, but we are now have a plan to go the middle of February to California, and we're going to run an emission test in the SEMA garage.
Oh, excellent. Great.
And then I'm going to submit that test to CARB.
Excellent. That's fantastic, Mike. And for our viewers who aren't familiar with the SEMA garage, so SEMA is the trade organization that Mike and I are active in. It's the Specialty Equipment Market Association, if I have all those letters right and that acronym correct. But it's a great organization. They hold the SEMA show every year out in Vegas, an incredible show for our industry. And they also have some great resources for member companies, such as the SEMA Garage, which if any member companies need emissions testing, help trying to validate a part, getting CARB approval, getting an executive order number, fantastic resource. And we always encourage our manufacturers to work with them because there's just a lot of resources there, a lot of really, really smart people. And we've had some great dealings with those folks over the years, Mike. So that's awesome. I can't wait to hear after you do that, how everything comes out and how that goes. I'm sure it's going to be all good, as they say, and you'll get some pretty cool results from it. Speaking of results, what kind of power does the combination make? And can you talk a little bit about exactly what is the engine? How many cubic inches is it? How much boost? All that kind of stuff.
Sure. All right. So let me first say this, Al, because this is the number one most confusing thing to everybody when we talk about hydrogen. Because people say there are cars out there that run on hydrogen today, and there are not. There are fuel cell cars. And the main difference between a fuel cell and what we've done, in a fuel cell, there's a membrane. You inject hydrogen into the membrane and you physically burn it inside the membrane. When you do that, that membrane generates electricity. And the electricity is then used to run electric wheel motors that drive whatever you're driving. All right, that's what Toyota builds a car like that. Nissan builds one. But they're really electric cars, and they use hydrogen to generate electricity to recharge the battery pack. In our case, we inject hydrogen direct into the port. It's drawn into the engine in the traditional fashion of gasoline, and then it's burned. So we actually burn the hydrogen inside an internal combustion engine. We light it with spark plugs, just the way you light gasoline, and that's how we generate the power. So that's different than a lot of people assume it to be. So it's I wanted to clarify that first off. So
Yeah, I'm glad you did that, Mike, because I had a pretty good friend who actually made the comment to me, well, that's been done before. And I said, no. I said, when we get into it, you'll understand. There are
yeah,
vehicles running around on hydrogen. I'd call it hydrogen fuel cell technology, right, Mike? But
yeah,
not like
exactly.
this. Yeah,
Yeah,
this is
exactly. So
this is pretty awesome. So
yeah,
first
and
first to do it.
there are people in the past that have made internal combustion engines run on hydrogen. There's been a number of people try it. Unfortunately, most had great aspirations and were never successful. A few even lost their lives doing it.
Mm,
So it's not simple, but it can certainly be done, right?
mm.
So in our case, we have a 6.2 liter LS. We started with a LS3 block, and we made a number of modifications, and we made those because this is a development truck, right? I mean, it's a high-end show truck with all the best of everything, but you'll see when I show it, there's wires all over it and thermocouples everywhere and all kinds of crazy stuff going on because it's the only one, so we have to do that with it. So we have pressure transducers set up and a lot of other things. So, but anyway, so in this specific engine, as I said, we started with the LS3 block. And I apologize if you hear a little background noise. We're actually in one of my shops working. So,
No
and I'm
worries,
not
Mike.
going
You
to
got
stop.
work to do, right? No
That's it.
problem.
So, customer cars have to get done. So,
Yes, sir.
but first to cool the pistons, hydrogen burns it 3 times as fast as gasoline, so you can generate a lot of heat. It also contains 3 times the energy of gasoline, so you can again build a lot of heat. We wanted to be prepared for that, so we kind of overbuilt the engine. So we added oil squirters on all 8 pistons. The crankshaft and the connecting rods are from K1. The pistons themselves, and we ran a shorter connecting rod than you would traditionally do, and we did that to get a larger piston. We added some piston mass. We wanted to give the piston, if you're familiar with LS engines at all, you know that they have a very, very small piston, and we
Mhm.
wanted to increase that a little bit to for the opportunity of more temperature transfer.
So, Mike, did
So
you increase the skirt length or the distance to the top ring or kind of everything?
well, all. So we increased the skirt length and moved the pin down because we ran a shorter rod. And then we moved the upper ring lands, all ring lands actually down a little to get it away from the heat. Just like if you were to run, say, nitrous oxide on one, we always move the ring lands down to try and help protect them. And we
Okay.
did that same thing here. It puts more material at the top of the piston, more opportunity to transfer temperature out.
Did you
So
gas port the pistons or run a
we did
gas
not.
ported ring, Mike? Okay.
No, no, you don't need that at all. So we're running a special ring. Weisco created the pistons for us, and then we went through and analyzed. It's actually a steel ring, and it's
Oh,
specifically designed for temperature. All right.
okay. How
So
thick, Mike? Can you share how thick the ring pack is?
yeah, they're still small. They're 1 millimeter, 1 millimeter, 3 millimeter.
Okay.
So, and then we added. So we're using SCE gaskets throughout the engine. So we use they make a special head gasket that they've designed for high pressure, and we use one of those sets in it. We have a custom ground camshaft that comp ground for us specifically. I'm not going to share the specs on it, but I will tell you that it's close to a production cam,
Oh,
and the center line is very open. So we're 122.5 on a center line.
wow.
So
Wow.
and we did that intentionally to try and eliminate exhaust revision into the intake, reversion
Okay.
into the intake. So we're trying to eliminate that, and so the wide center line helps that.
So I'm
That
assuming, Mike, no overlap, or is it just very
very
minimal?
very minimal,
Okay.
very minimal
Interesting.
overlap. Yeah, and we did that intentionally, like I say, to try and stop it, to keep it from pushing any hydrogen back into the intake manifold. So we changed the exhaust valves to an Inconel. Uh, we have a Magnuson 2650 supercharger on top of it.
Okay.
So we use that exactly the way it's designed. It's a brand new version. So it works exceptionally well. We're running, as an example, we're 9-to-1 compression, and we're now set at 15 pounds of boost.
Oh, wow.
And we can do that because hydrogen is extremely resistant to detonation. So, and we also, don't run much, if any, advanced because the hydrogen lights so quick that we don't have to run a bunch of advanced to take advantage of it. So,
How much timing, Mike?
we're still working through that, but we're around 0.
Really? No kidding.
Yeah, a little bit more as we bring the RPM up, but yeah, it burns 3 times the rate, so we don't have to run a lot of advance. So
Interesting.
yep. So it, but the rest of the engine is kind of traditional. Cook's made us a set of what I'm going to call mid-length shorty headers, so they have a lot of nice curves in them to get the tube length longer. They're all, of course, thermocoupled because we monitor exhaust gas temperature on all 8 cylinders all the time. We run 16 fuel injectors. So we run 8 in the traditional location, and then we have 8 more. We machined an adapter that goes between the intercooler and the supercharger itself, and we run 8 more injectors there.
So it's not direct injection then, Mike. It's traditional style.
It is port fuel injection. Yep.
Okay.
So we do that because of injector size, not because of the 16 injectors. All of those parts are experimental. And there was never the thought that anybody would be crazy enough to build a supercharged V8 and put it on hydrogen. So any of the experimental parts are designed for small engine. So we just couldn't get enough volume. And as we go forward, adding volume through the injector horsepower with our existing package.
Mike, on the injectors, in the traditional gasoline powered injector side, there's low impedance and high impedance injectors. I'm assuming these things got to draw quite a few amps just to be able to open against the pressure that you're pushing the hydrogen up at. Is that correct, or is that not accurate?
Yeah, that's not accurate. So because we run the tank at 350 bar, so we're 300 so we're 5,074 psi roughly. That's what the tank has. But at the engine, we regulate it down to 7 bar. So that's just over 100 psi. So we're not running the huge pressure on the top side of the injector. So interestingly enough, that's quite different. We're using a Bosch ECM, an experimental ECM, to run this. But as you know, anybody that plays with this stuff knows in traditional, we run power to all the injectors, and then the ECM controls them to fire the injector. In this case, ECM supplies the power and the ground to the injector.
Really? No kidding. So it's not a switch to ground.
Nope.
Interesting.
Nope. They control the whole thing.
Wow.
So, and they do that. They get finer control of it. So we need that to be able to more precisely control it.
That's interesting, Mike. So the rest of the engine, do you have any exotic coatings? Is there anything that you had to do to, that I would assume with hydrogen, it burns so much differently than traditional gasoline that any issue with, cylinder wetting from the water that's produced during the combustion process, any weird stuff like that you're seeing so far?
No, nothing. And all of that's been perfect. We did not coat anything. We looked at all the different coatings available, and we coated the skirts of the piston, but not the top. And the reason we didn't is because we can hit temperatures that would actually burn the coating off the top of it. So, and we didn't want to take that chance. Weisco didn't believe it was necessary based on the information we provided. And, I argue with a lot of people sometimes, but I'm not going to argue with the people that build their own parts.
Yeah, they build pistons for a living. They are pretty darn good at it. That's for sure. So
yeah. I called Vic and Trey and talked to those guys, and it's like, look, this is where I'm going. Of course, they thought I was nuts. And, a lot of people questioned whether we would ever be able to make it work, and it does. So, but here's the interesting thing about all the engine modifications that we made. We can run, and we did all of these because it's a development car. We're playing with things that you'll never do once we go to real available production style kits. And we can run a bone stock production engine on hydrogen with no changes.
Wow.
No physical changes to the engine components. None of them are required to run on hydrogen. We're actually learning things as we go through this process where we could actually extend the life of engines. One, we have no carbon, so you never worry about carbon building up on valves or in intake ports, direct injected stuff. The oil will stay clean basically forever because there's never any carbon going past the rings. And
wow, that's incredible.
So all of those things, yeah. We're actually we've identified opportunities to control engine temperature based on fuel mixture. So
what do you see for EGTs, Mike?
They're typically in the, as high as like 1200 or where we're at. We can drive them a lot higher. So, we're in most of ours are in the 800 range, so, but we can.
That's surprising because that's actually on the cool side related to, typical internal combustion stuff. That's really interesting.
We can move them all over. That's the amazing thing. We've learned a lot and we continue to learn, right, as we go through this stuff. So we ran a 20-minute test at idle RPM, and we were able to adjust the fuel mixture, and we had engine temperature. The max engine temperature in the coolant we saw was 157 F.
Wow.
So we can actually cool the engine with hydrogen.
That is, wow. Boy, this opens up a whole lot of you and I got to talk off camera, Mike, because boy, there's a whole lot of thoughts singing through my head with what else you could do with this. That is pretty fascinating. Have you found the knock limit of hydrogen yet?
No, it's so good. We never even put knock sensors. We didn't even put them in as a calibratable event. So no knock sensors required. We have zero hint of detonation in any form or fashion.
Wow. Interesting, Mike. What about do you measure, so typical internal combustion stuff, you'd measure brake specific fuel consumption on the dyno. Is there any relevant measure of that for hydrogen, or is that, that's so gasoline powered stuff and not relevant?
No, there's calculations you can do to run that, right? And we're not far enough in long-term drivability, to do those kinds of tests yet. But we're making progress in that direction. We should be on the engine dyno or on the chassis dyno to start running some of that data probably right after Christmas.
Okay. Interesting.
But there's a correlation. I mean, we've been able to mathematically, our tank is 3 kilograms, and that's equal to roughly 16 gallons. And our calculations say that we have about a 3.5 to possibly 4 hour runtime based on that.
So really, you think that
early,
highway, say you go out for a drive on the highway, can you go 200 miles with one tank of hydrogen?
Yeah, I think that's fairly easy. That's a somewhat conservative number.
Wow, that is cool. What kind of power does it make, Mike? What have you made so far?
Well, we're not even to those yet. So I mean, we analytically, our target and our expected goal is 500 horsepower with where we're at.
Okay.
So, and that's injector limited. So as we get bigger injectors, then we'll be able to make more power. Typical NA in the work we've done, the work Bosch has done, the work we've done. If you run an NA application, the hydrogen physically takes about 25% of the port volume to move the hydrogen in. So just simple math tells you we're going to make about 25%, 20% less power in an NA. Now, as we run it higher with, as we can run higher boost. So with any kind of boosted application, we'll be able to get that power back.
Okay, interesting. In a normal internal combustion gas-powered engine, Mike, stoichiometric is 14.7 to 1. And for our viewers not familiar with this geeky stuff Mike and I are talking about, that is how many parts air to fuel. So that's referred to as air-fuel ratio. So basically 14.7 parts of air to 1 part of fuel. That makes the engine run appropriately. Is there a stoichiometric ratio, Mike, for hydrogen, or do you run it a ton richer where it's got to be 8 to 1, or what does that look like? Is there anything relevant there?
There is. Right now we're still working on that.
Okay.
But we're in the 100 to 1 range.
I'm sorry, in the what?
100 to 1.
Holy wow. Boy, that's different.
Yeah, it's completely different. But realize it contains 3 times the energy a given volume of hydrogen does to gasoline.
Wow. So what that almost leads me to believe, Mike, it almost leads me to believe that you're capturing a significant amount more energy to do work in the engine than generating it into heat. And that kind of is relevant to what you said about the coolant temperature. And you ran the thing forever on the dyno and it goes up to 157 degrees, which, combustion stuff, you'd be at, 210 and the fans would be kicking on and everything else the whole time just to keep it at 210 or 205 or 200 or whatever. So that is really, really interesting. Totally different then. So you gotta literally recalibrate your way of thinking about, all the different strategies and everything else. So this is a huge departure from typical internal combustion stuff.
Yeah. Well, and here's why that happens. And here's another potential advantage. So it happens because the fuel, the hydrogen, burns at 3 times the rate of gasoline. So it allows us to control the mixture more precisely. One of the biggest challenges in an internal combustion engine when trying to target emissions is physical time that it takes the fuel to burn in the combustion chamber. So the larger the bore, the longer it takes. So, and RPM is a measurement of that. So one of the emissions is when you go to, it's an example, a 4 1/8 or a 4 1/4 inch bore, it takes so much longer for the flame to burn across the head of the piston. So even in like a 4-inch bore application, normally kind of the peak RPM where you can still be efficient with that's about 7,000 RPM. Once you exceed 7,000, the burn time becomes much more of an issue, right? So as an example, you remember the big block Chevy, the last ones they built, the 8.1s?
Yeah.
They ran a 4 3/8 inch stroke and a smaller bore. They did that for emissions. So that's why the stroke doesn't affect it, the bore does. So in our case, because we can burn at 3 times the speed, we have the opportunity with supporting components and to actually run 20,000 RPM as an example compared to that 7,000. So the opportunities to do those kinds of things are, only limited by the technology of the physical components, right?
So Mike, if you had to kind of define and I'm going to say optimal right now, just based on what you know today, and I know you've learned a lot, you're going to continue to learn a lot, but the optimal bore to stroke ratio for a hydrogen powered engine, I'm assuming then small bore, or would it be big bore, tiny stroke?
It doesn't care.
Okay. So
the hydrogen burns so fast and we have so much ability to control it with the Bosch components that I'm using. We don't care. You could do a You could do a 5-inch stroke with a 5-inch bore, or you could do we get a little bit of an influence, but nothing like you do with gasoline. So
Interesting.
we just don't care.
So, Mike, one of our viewers, Crazy Horsepower is their screen name. Are you introducing a liquid or near liquid fuel charge? Great question.
Yeah, it's a good question. No, we're using 100% gas. So we use all the hydrogen as a gaseous state, no liquid.
Interesting. And Mike, is the fuel injector a traditional like pintle style fuel injector, very similar to a gas engine, or is it totally completely different?
It's similar. Everything inside it's different, right? One, to deal with the hydrogen, uh, and two, it's because of the size of it, right? So at 100 psi, unless it's a race injector, no street injectors will really operate efficiently in that range. So
Okay.
it's different but the same. So
Okay.
if you looked at them, if I didn't tell you it was hydrogen and you looked at it and you didn't physically look into the end of it, if you just look at the injector, it looks the same. Special connectors, obviously, but that's one of the things we're working on as we go to production. How do we effectively, the goal here is going to be to retrofit, and there are some differences that we're going to try and compensate for in the production design.
Very good. Another customer, Mike, Go Garage, wants to know. So we already got a customer, Mike. So we got to set up a distribution piece through Summit here. When will this engine be available for purchase, and what would the cost be? And it's hard to answer that, I know, because you've got one of one right now, right?
Yeah, exactly. And so that's all the things that we're working on right now. So the cost, there's a savings of scale, right? When you start building parts and you start selling parts, it's like, if you build one, what's it cost? If you build 10, what's it cost? You build 100, or you build 1,000, what's the cost, right? And we're working on that now. So the parts come from a multitude of suppliers. So I'm working on that, right? And some of them, a lot of them are not production based. And the response and the number of, as an example, the number of municipalities that have reached out to me, the numbers of other large number of component, like 300 cars as an example.
Mm-hmm.
So that kind of that drives volume. And a tank manufacturer that built these kind of almost one-off tanks we do, I don't know their exact numbers, but I'd be surprised if they sold 100 of these a year. And we could do realistically, we could do 1,000 of them in an order.
Yeah.
Right.
Mike, I've got some ideas for specific vehicle families that would use this, and you and I will talk offline about that. But I'm thinking of vehicles that are limited use with limited range, used few times a day. That would this technology for them, it is perfect. And there's been a lot of talk about, well, those type of vehicles are going to be retrofitted with battery electric vehicle. Well, you still got to make the electricity to power a battery electric vehicle. And a lot of people miss that point. There's a very big misconception with battery electric that, well, you just plug it into the wall and, the energy, it's pollution free. Well, no, it's not. A very tiny percent of our energy is made from wind and solar, and it will get better, and it should get more over time. But there's trade-offs with that. The majority of electricity generated today does not come from wind and solar. So there's that misnomer is out there. Your technology, however, if you can extract hydrogen from the atmosphere, retrofit existing vehicles with a control system, the fuel tank, the fuel delivery, to me, that's a far, far better solution than the production of batteries. You still have to generate the electricity to power those, the lithium mining. I mean, I could go on and talk about that, but there's a lot of byproducts that people are completely missing when they look at battery electric vehicle. that are significant, and they are a big negative impact to the environment. And I think your solution, especially in some of these vehicle applications, could be absolutely fantastic, and in fact, a better solution than that.
Yeah, well, today they've invented a process they call green hydrogen. Now we can run any hydrogen, green, what some people want to call dirty hydrogen. We can do either of those, right, in our application. Green hydrogen is manufactured with zero carbon footprint. Okay. So they create the hydrogen with zero emission. We take that hydrogen and we turn it into transportation, so extract the energy and turn it into transportation with zero emission. We have no carbon monoxide. We can create a small amount of hydrocarbon if we get the fuel mixture way, 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 way off. Or if an engine burns oil, it will create a minuscule amount. But we use it with zero carbon footprint to provide transportation. It's the only true, as of today, zero impact environmentally for creating transportation. Now, the other positives are there are just over 50 fueling stations, hydrogen fueling stations in California. There are 40 more in process. And in California, they just passed some legislative things. And as part of EV, electric vehicle support, because fuel cell vehicles burn hydrogen, they're adding 100 additional hydrogen fueling stations in California. Some of those stations, one of them already currently operating, they don't truck hydrogen to it. They manufacture it on site. So they actually subtract the moisture from the air and create hydrogen. So you no longer have to transport it. You don't have to run dirty semis up and down the road until we put them on hydrogen to transport it. I mean, it just answers all of those questions. The beauty part to it is that you refill in about 5 minutes. So you pull into a station, it's a quick connect, you hook it to the tank, punch the button, and it fills your tank. Right? And you unhook the hose and you drive off. Electric takes, they claim they have quick charge if you only need to go a few miles, but it really takes, depending on the application, 8 to 12 hours. If you try and do it with solar, it can extend that by up to, solar operates at about 15% efficiency. So figure that out.
Yeah.
You had a 1 hour charge time and you do it with solar. Now you have a 15-hour, or at least an 8-hour charge. So there's lots to that, right?
Yeah, and our personal experience, Mike, with our Tesla. So we have the Model 3 project car that I believe you're familiar with. We drove it down to the ECTA meet in Blytheville, Arkansas. We did this lengthy road trip, documented how long it took to charge, what the equivalent mile per gallon of a vehicle would be, like dollar per mile type of thing. And, we looked at all these different metrics. And the fact is right now for an EV, with our Tesla, about 200 miles is the range you get out of it. And the charge time's well over an hour. So in your case, if you have the range is the same, but it's a 5-minute refill, that is tremendous. I mean, that is much better than what current battery electric technology is. And granted, I don't want anybody to think that I don't like battery electric vehicles. I like anything fast. I like technology. And battery technology will advance, it will develop, it will get better. But I firmly believe that there needs to be options available to customers. So if someone wants to drive a battery electric vehicle every day because they've got solar panels on their roof, they want to charge a vehicle at their house, awesome. If somebody else wants the option of a hydrogen-powered internal combustion vehicle that still produces zero emissions, why wouldn't you go that route? So I think over time that as this technology develops and as the OEs begin to look around a little bit, I really believe a huge mistake is thinking that the whole world wants to embrace battery electric vehicles. It really depends on how you have to get where you're going and if you have time constraints and how far you're going to travel. For someone taking a 800-mile road trip like we did to Arkansas, it's over 4 hours to charge the vehicle to get to that point. it is not highly convenient. Was it a horrible experience? No, not really. You can plan your trip around lunch hours and things. But Mike, this technology to me is very exciting because of that 5-minute recharge time. That's huge. I mean, that is a game changer.
Yeah. Well, so I just went to PRI, right? I live outside of Detroit. So it's about 270 miles roughly. They just recently ran a test. I towed the 48 pickup there. So in my trailer, and they just recently ran a test on the Riven truck, and it depleted the energy, lost 62% of its battery life, the difference between running with an open trailer and a car on it and without. So you got
Wow.
40%, roughly 48%, no, yeah, 38% of the life towing a trailer. So, I couldn't have got to Indy without stopping to recharge, right? Probably twice.
Yeah.
I have a place over on the west side of the state where I go play with my Jeeps and that kind of stuff. It's 200 miles. I would have to put a charging station in at my fifth wheel trailer so I could recharge my vehicle to get home.
Yeah.
Now, if you're around town, and there are places it works really well, and they'll continue to improve that. They're spending billions right now developing that, right? And and so they'll make it better. They look how far it's come, and it'll just continue. But it's not every answer, right? I had and to answer the question that we had last, you will not, when we release our package, our goal is that you will not have to replace your engine. You'll be able to run your existing engine, internal combustion, 4-stroke engine, on our package with our hydrogen and not have to change anything in the engine. So that's the goal. As far as cost, I can't answer that yet because it's too early. Our goal is to bring it in as cheap as possible. Today there are 90 million registered internal combustion engine powered vehicles in the U.S. Right? Are you going to throw all those away?
Right.
I had
Exactly,
a
Mike.
bus company reach out to me, and they would do our hydrogen conversion tomorrow if we had it available.
Yep.
And as he explained, they have 200 buses that all run on gasoline, and his only other option will be to scrap all 200 and buy 200 more.
Yep.
Right? So this is not the answer to everything, but it's a zero emission answer and it lets us, it still sounds like a V8. It still drives like a traditional car. It still does all of those things, and it's an option.
Yep. Exactly, Mike. Mike, couple questions from our viewers. Let me see here. So Michael Troxler asked the question, what's the post-combustion byproduct of this process? You and I have talked a bit about that. You want to elaborate a little bit on that?
Sure. The main byproduct is water. So it puts water out the tailpipes. There's no after treatment. There's no catalytic converters required. There's no DPF. There's none of that, right? And the byproduct is water. There's a minuscule and very, very minuscule amount of N2O that comes out. And it's so small you almost can't measure it. But the byproduct is water. And a lot of people, comment about, we're going to have, freezing on the roads and this and that. Once the exhaust comes of temperature, you run it long enough to bring the exhaust to temperature, it no longer puts water on the ground. It just comes out as steam.
Yeah. Yep.
So
Mike,
that's
another question. That's excellent. One other question, Derek, if you could scroll up a little bit on the comments I just saw. It was, what am I looking at? Fontro, I believe it's Fontro, asked a question. He just joined the session, 100% running off of hydrogen. So no other fuel, Mike?
No.
100% hydrogen.
100% hydrogen. It's the strangest thing when it runs because you stand behind it and we ran tailpipes all the way out the back and dump under the back bumper. But when it runs, there's absolutely no smell, none at all.
So Mike, you and I joked when you first told me about this project about, hey, if you want to debut it at a show and really make a bang, take a gas mask and run the exhaust pipe into the gas mask, strap it on, fire it up, have people freak out because they think you're going to come out with a third eyeball growing out of your head. But the reality is, you probably could do that, and you'd probably get away with it, and you'd live to tell about it. Because again, it is, yeah,
just the heat. That you got to worry about the heat, right? But the water that comes out, if you catch the water, you could actually drink.
Wow. Yeah, I might not try that one, but then again, it'd be pretty amazing. Mike, how do you so let's talk a little bit about the truck. How do you store the hydrogen? Because I know when other folks I've talked to and mentioned about hydrogen, they immediately freak out. They go, "Oh, it worked great for the Zeppelin." I'm like, technology's changed a little bit from the picture that's on the cover of that Led Zeppelin album of the crashing Zeppelin back in the day. Yeah. It's not the same. But what do you do in the truck for the storage of hydrogen, and how do you store that, and how do you manage that?
So we store it we have a tank. It's a spun aluminum tank. It's like a big tube. And that tank is spun aluminum, has a rubber bladder inside it, and then the outside of it's wrapped with carbon fiber. So the tank that we use was designed for a fuel cell bus, and they use multiples of them. But this was designed for a fuel cell bus. Like I say, it holds almost 3 kilograms, and it's DOT approved. So it's been certified for crash and for all those things. So hydrogen is the lightest element known to man. So I actually had a chemist and a chemistry teacher for 20 years that stopped by at PRI. And she had some amazing insight. She was so excited to see a vehicle that ran on hydrogen. And one of the things she shared with me that I did not know, I knew it was light, but I didn't know how to scale it, right? And she said they have a numeric numbering system for weight when it comes to gas. Any gas fits into this category, and they've defined a weight for it. Hydrogen is the weight, the number they've assigned to hydrogen is number 2, the number 2. So obviously that's extremely light. The air around us that we breathe is number 34. Right?
Wow.
So that gives you an idea how light it is. If you escape hydrogen, it goes straight up as fast as it can. Right? So Bosch ran a test where they took hydrogen, they created a hydrogen leak, and then they lit it on fire. The hydrogen escaped so fast that as it went up, you got a woof when it lit, but it went straight up so fast it actually put itself out because it mixed with the atmosphere as it went. It never even burnt the electrical tape on the connectors they used to light it. Okay.
Wow.
So hydrogen is less volatile than gasoline. When you escape hydrogen, like I say, it goes straight up. A lot of people talk about the Hindenburg, and I've had that 10,000 people tell me that joke, right? But the reality of it is virtually no one died in the Hindenburg because of the hydrogen. When they hit the power line and it lit the hydrogen escaped immediately. That's why the thing crashed. But the cloth that they had used to wrap it caught on fire. The cloth came down and burned people. Imagine if the Hindenburg had been filled with gasoline and they punctured it and then lit it on fire. Gas is heavier than air. It's going to go straight down and coat everything underneath it. It continues to burn for at least 3 times the amount of time that hydrogen will. And that's if it doesn't get anything else hot enough to continue, right? So a lot of people look at that, and it's been, and I'll admit, till I started down this path, I didn't really study it, right? Because I'm concerned about everything else involved. And I wouldn't let myself get involved in something that was that dangerous, right?
Sure.
Now, we worry about it. We track it. I have hydrogen leak detectors here. Actually, one sitting on the bench behind me. So this is for detecting hydrogen. We test everything. We go over every connection. There are things today that are done that have been created that never existed, right? As an example, if you're going to put hydrogen in a stainless steel line and travel it through that, and you don't want it to leak, you have to use 1/4-inch wall stainless. Okay. But the military had a need for a flexible line that was not permeable, not for hydrogen, for something else. So they worked and invented that line. It's commercially available today. And it's a flexible line that hydrogen will not escape through. Right?
Wow.
So there are so many things like that, right, that exist today. The technology, the way that the fuel regulator I use is made, the way the tank's made. I mean, imagine what DOT put them through to certify that, right?
Oh yeah. Yeah.
I mean, it's all of those things. Today, by standards, hydrogen is safer than gasoline to use.
Yep. Totally believe you, Mike. Mike, couple questions on hydrogen aside from the safety issue. How expensive is it when you compare it to gasoline? So if your truck has a range of 200 miles, you fill the tank up, you go 200 miles, what's the cost of that? And I would assume as this is adopted more, it's going to get cheaper, right? Because like you
Right.
said earlier, it's supply and demand based.
Yep.
What does that look like right now? What do you think it'll look like in a couple of years?
Well, the expectation for the future, and the president of Bosch has gone on record and said that they expect hydrogen prices to drop 50% as it becomes more commercially available. Okay. So using California's numbers, because they're the only ones that commercially sell hydrogen today. So to the public, just at gas stations, you pull in and fill your hydrogen fuel cell. So in California today, gasoline, unleaded 87 octane, is just at or just over $5 a gallon. If we do the correlation and do the math based on hydrogen to gasoline, hydrogen today is about $3.50 a gallon.
Wow. So today it is actually cheaper than running traditional gasoline in California.
Yeah, by roughly a third.
Wow. That's pretty awesome. Mike, is there any downside that you can see of running a vehicle on hydrogen? And is there a finite supply of it?
There's more capability and more raw to generate hydrogen than anything else in the world. You can make it out of the atmosphere. The air that's around me or you right now, with a machine, we could literally generate hydrogen from the air around us, right? So it's typically generated. They get it from natural gas, wells and things like that, where the hydrogen's actually on top of the natural gas. So that's used for that. It's easily manufactured from water. So there's like a limitless supply. And the interesting part is if you start with water, create hydrogen, use the hydrogen, it turns back to water. So then you can recycle it and do it over again. But,
Wow.
so there's not really a limit there. I think right now the challenges are, maintaining the same power level you had on gasoline. That's an issue with port fuel injection. With direct injection, we don't believe that exists. We believe that actually with some enhancements to a direct injected application, we can actually increase the power being naturally aspirated. But it requires specific injectors. There's some piston opportunities. If you understand how direct injected engines actually work, there's some more opportunity with pistons for control and energy release and all those things. Combustion chambers. There's a lot. In the past, people have played with hydrogen. The technology, that the way we got better with emissions and the way we got better with performance is making engines more efficient. Cylinder head designs today, I remember going back just when the LS first came out, the LS cylinder head, the first cathedral port, outflowed the GM 6th generation race head for a small block, and the production head outflowed it. Right?
Yeah.
So
Yeah.
that technology allows us better advantage of this. Right now, aside from the cost of the conversion and just the fact that there's not hydrogen available all over the place, those are really the only disadvantages. And there's some smart people out there, right? And they're working on that. I got a call from a U.S. senator, and he asked me, not from my state, from another state, and he asked me what he could do to help make hydrogen available across the country, and what else could he do to help get my Bosch is involved in this with me. What does it take to get that available to the public, and how fast can we do it?
Awesome. Mike, can you give us a walk around of the truck? Is there any way that you could do that today? So we can
it may be shaky at first, but absolutely. So let me
awesome.
Let me try and do that. So I'm going to try and walk over with the camera and see. So this is the engine compartment. As you see, the engine, there's extra lines. We run to both sets of injectors, both rails at the same time. The piece up on the firewall is the fuel injector, or the regulator. You'll see that mounted over there.
Okay.
16 injectors. We use a traditional GM style throttle body, electronically controlled. We still run that. This truck has AC. It has all of the features, right? It's intercooled. You see a chrome breather at the back. Maybe I can show a little better. Right behind the supercharger. Yep. We trap and then vent all of the internal air from the engine out through that. So if there were any hydrogen, we want to release it at the highest point and keep it away from things. So that's kind of the basis of what you see. You see wires all over because we're running this and testing with it. We were tuning on it last night. So they'd probably be working in it now, but I held them off so we could do this. So, but anyway, that's the engine package. And you can see this is a 48 Chevy truck. It's a high-end truck. I mean, it's on a TCI chassis. It's all forged line wheels, bare brakes. I mean, all of the best of everything. The body is called Passion Red Pearl is the color. You can see every piece of chrome. I CNC'd these emblems that we put on the truck. Oh, come on, where the hell is it? So these emblems, they're on the side of the hood. We call it 0. So nice. We're pretty proud of that. And I hand painted each one of those things. So I can tell you that was no fun, but I did it on a Sunday when nobody else was here. So going inside the truck, we put a 55 Olds dash that we narrowed and put inside the truck. That's all here. All of the interior is all leather. That's all done in-house. We manufacture the armrests and all the other components. We made the seat. Has all kicker audio all hidden throughout it. So it's got 1,000 watts of audio.
Wow.
It sits really low. If you can't tell, it's literally just inches off the ground. And going to the bed, that's where the hydrogen tank is. So we even left the decals on it to say it's DOT certified, because I don't want to have that conversation with somebody that doesn't understand. But anyway, all finished wood. We even machined grommets to run through. We actually have the line out right now. We're running it on portable tanks. So we pulled the feed line out of the bed, but that goes in there normally. There's electronic controls on the tank where the ECM opens a valve to let the hydrogen come to the front. And then it has a blow-off safety in the front and in the rear. Those are vented out into the sides of the truck. So if we ever were to have a high-pressure thing where it popped one of those valves, they'll vent out the side and then disperse into the atmosphere. So pretty standard stuff, looking at the back of it, right? We did all shaved bumpers with no fasteners and the zero emblem. Shameless plug for my other company, of course, Diversified Creations. So that's where we built it. This truck was built ground up, including body, paint, and everything in 10 weeks. So
wow.
That's we do our own paint in-house. We do our own interior in-house. We do everything in-house. So, but that's kind of a brief walk around of the truck, and it's we're pretty darn happy with it. So,
Well, it's beautiful, Mike. Beautiful truck.
well, thank you.
So Cameron White asked a question. So what's it sound like? And in our earlier conversation, Mike, you had said, really, it sounds just like any other LS-based engine.
Yeah, it sounds just like it was on gasoline. So, but if you want to be patient with me, I'll fire it up.
Yeah, let's do it. So we need some hold music here while Mike is getting ready to fire up.
So the extended crank time was my fault because I let go of the key too soon. So you have to maintain a little longer key on to do that. But it's in a cold start mode right now, so it's open loop. You hear a lot of injector, but that's because there's 16 of them.
Okay.
So there's the dash all lit up. I love
Awesome.
the dash. We've even been able to reconfigure the gas gauge, and it reads the hydrogen pressure in the tank.
Oh, no kidding. That's cool.
So we have a functional gas gauge. You can see a little water blowing out. It's cold. That's the only byproduct of it running. I mean, I could literally sit here all day long and never get a headache because there's no smell.
Boy, that's awesome, Mike. Really cool. Well, Mike, when the weather's better, I got to come up and visit you, and we got to go hit Woodward in your truck. We got to do that.
Yeah, well, this is my wife's truck, so that we built this for her.
Oh, nice.
She's planning to drive it, and I'm planning to let her drive it. That's one of her biggest concerns once we built this and did this is that how do you, are you going to be dragging my truck all over the country and showing it off, and I don't get to drive it? So.
We got to build another one, Mike. I mean, so
we are, and the response has been so big to this, and there's so many people that have contacted me. We're gonna. The next step is to make a plan for production level parts, and then we'll build another vehicle of some kind. I don't know what that's going to be yet, but and then so we're going to build another vehicle and put it on hydrogen and let it do what it does, right? And so we'll use it for testing and development. It won't be at this level, so that way I can quit, having to worry about covering the fenders all the time and all that stuff as we work on it. So, but there's a lot to this. We're learning every day. We get better and better. We haven't started working cold start yet, and like I say, if I had have held the key a little longer, it would have fired up the first time. So, but I'm not normally the guy starting it. The calibrators are, and they warned me of that, and it slipped right out of my head. So, but
no No worries, Mike. Hey, you're the first to have ever done this. So it's remarkable that within a very short period of time, you have a running, driving vehicle that runs on hydrogen. It's amazing, Mike. And you and I have known each other and been friends for a long, long time. And it seems like every few years there's something you're doing where I'm like, wait a minute, what? What are you working on? And in this one, Mike, I don't know how you're going to top this. I mean, we did the Reggie Jackson car together years ago, Project X, before it got electrified, back when it was a internal combustion car, and a lot of fun stuff over the years. And this one, unbelievable. I mean, congratulations. It's a fantastic project. It's cool to see you develop it. And I really appreciate your time today. I know you got two businesses to run. You got this, I don't know, little hydrogen powered side project with Bosch and Phillips you're working on. I mean, you're a pretty busy guy, and I really appreciate you taking time out of your day and walking us through it. It is absolutely awesome. Hey, and Cameron White made the comment, first Hellcat swap, first hydrogen conversion. Mike is brilliant. Cameron, you are not kidding. You are absolutely spot on. So, Mike, I'd say the next one you got to do is a hydrogen-powered Hellcat. I mean, I'm just saying, you are the Mopar guy, so,
yeah,
that's actually future.
That's actually kind of, there's some stuff like that in the plans. So, the best I can tell you is we'll be doing a bunch of promotion this year. We're going to launch the website Arrington-Hydrogen. So that's where a lot of this information will be. That's where we're going to link a lot of the media and the things like this that we've done, and those will be out there. People are asking a lot of questions, and they should. I'd be really disappointed if people didn't, right? So
Sure.
that's all part of this. And after I built the Rampage, for people that don't know, it's a Dodge Rampage 84 with a tube chassis and a mid-engine stack-injected Gen 3 Hemi in it that I race and I pound on. So people for 2 years asked me what I was going to do to top that when I went back to SEMA. And now they know. So the best I can tell you is, unless I have something happen, I'm not done yet. So we got a plan for SEMA 2022, and hang on.
That's awesome, Mike. Well, Mike, again, thanks for your time today. Summit customers and everyone watching, thank you so much for joining us today. It's really an honor for me to have the opportunity to do this. I want to thank the entire Summit team, all of our video team, our internet marketing folks, and all the team at Summit. It's great to be able to have opportunities like this, Mike, and we've been friends a long time. I love learning about new things, and you have taught me so much with this project, as well as all of our viewers. So thank you again, and have a Merry Christmas and a very Happy New Year, Mike, if we don't talk, but I'm sure we'll be talking through then. I got a lot more questions for you, so I'll be bugging you again,
Yeah, so if you're a SEMA member, for people that are, probably early March, late February, early March, we're going to do a SEMA session on this, on hydrogen and on all of that. So they've reached out to me and asked me to do that. Al, as always, you're in the front, so you got it early, but we're going to do something there, and we'll try and answer more questions if people have them. And I think it's a great opportunity. We were talking about it at PRI, and we said, what if you could flash forward 5 years to see what the results of this are? Right? So hopefully I live that long, and we'll do that. Merry Christmas, Al, and thank you, everybody that tuned in. I appreciate the questions, and appreciate you following what we do.
Yep, absolutely. Mike, thank you so much. Everyone have a Merry Christmas, Happy New Year, and we'll be bringing additional great American success stories to you through the Summit Racing Facebook Live. And Mike, you're the epitome of the great American success story. Super cool, and really, really happy for you. Real proud of you. It's super cool to see this. So thanks again, Mike.
Thank you.
Have a great day, everyone.